All right, let's get started now with normatives, or the prescriptive side of economics. This is lecture 3 in market institutions. So let's start with looking at a simple demand and supply curve. You've got your dollar terms or your monetary terms on the y-axis, your quantity terms on the x-axis. You've got your supply curve and your demand curve, and you've got an equilibrium where at this given price you've got the same quantity supplied as the quantity demanded. You should have seen this diagram and have understood it by now, and it forms the basis of sort of understanding that markets can equilibrate and clear is a very important insight to accept and understand and try to think always about these models in the real world. What do they tell you about the price of wheat in the market? Why is the price of wheat, for example, increasing in some case? Is supply decreasing or is demand increasing? And so always try and apply these models in the world outside. Now assume that we have a price ceiling. So you are not allowed to sell your item for more than this price. Well, the demand side thinks this is great, because now if at that price they're willing to demand a lot of supply. But actually suppliers are going to say, hold on, because they're not really willing to accept that amount. And so at that price they're only willing to supply a little bit, and your supply shrinks. So with that price ceiling in place, we're going to only have this amount of quantity, and with this amount of quantity you're going to get what we'll call an untapped win-win, an unharnessed potential gain from trade. Where does that potential gain from trade lie, and why is it important? So let's look at this point. This is a point where there was supply before the price ceiling was put in place, and there is no longer supply. So this untapped unit, what is the amount of money that the individual consuming it was willing to pay for that unit, is this blue dot. And in comparison, what is the amount that the supplier needs to supply that unit, is that amount. So the supplier was willing to supply that unit for less than the consumer was willing to pay for it. If one supplier and one consumer were able to get in the same place and say, let's break that price ceiling rule, the supplier would say, fine, I'll give you this item, and they'll find a price between these 2 points somewhere, right? They'll negotiate and they'll probably find any price between these 2 points. They'll both go away happy, because the consumer needs the unit, or wants the unit enough to be willing to pay a higher amount than the supplier needs or wants to supply it. A win-win has been left untapped because of the price ceiling in place. And so we can extend this to all of this area. In fact, let's cover the remaining spot. So this entire space is the space in which for each unit this is true. And this untapped potential can be described by this triangular region. This is called deadweight loss, and it is equal to the total untapped win-win that was available here. This leads very nicely to this idea of Pareto efficiency. What is Pareto efficiency? A situation is defined as Pareto efficient if and only if the only way to make one person better off is to make another person worse off. And a Pareto improvement is any change that makes someone better off without making anyone else worse off. Let's read that again. If the only way to make one person better off is to make another person worse off, that situation, there is no win-win available here. And so any win-wins possible have been exhausted. You are at the frontier or at the maximum point of efficiency that can be created in this fashion, and this is called Pareto efficiency. Pareto improvement is any change that makes someone better off without making anyone else worse off. In other words, if a win-win scenario exists, if that pairing of a supplier and a consumer that we mentioned with this graph was able to conduct that transaction, they would have made one another better off without making anyone else worse off. So Pareto improvement was possible when the price ceiling was operative. And there's the question of whether everything is Pareto efficient. And there's an argument that yes, in fact, every scenario that we are engaging with is Pareto efficient. So is everything Pareto efficient? What do we mean by that? All losers might be too difficult. And who are the losers? Let's give you an example of buying a used car. People who would have asked the seller for a ride are being made worse off even when he is getting a better price than he needs and the consumer is getting a lower price than he is willing to accept. In other words, a win-win scenario can create some externality on others who will not be able to benefit from others' property. And so you can always find some sort of a loser in nearly any exchange. And I'll come back to that example later. Pareto has the problem that even though it is conceptually a neat idea, there are very many Pareto outcomes, and to judge between them can be difficult. And again, we'll come back and explain this later on in this class. But first, let's talk about another concept of efficiency, which is Kaldor-Hicks efficiency. Kaldor-Hicks efficiency says that a situation is efficient if and only if the dollar value of social resources is maximized. What is the dollar value of social resources? The dollar value of social resources is really an idea that says we will assign a price tag to everything, whether that is the environment or social relations or even your feelings. If the thought experiment goes, if we could put a price tag on everything and we can create a scenario in which the sum of those price tags is maximized, then we've got, in a pure dollar terms, we've got a Kaldor-Hicks efficient scenario. I find that this is very hard to operationalize, because how do you compute the dollar value of social resources? And so ultimately Kaldor-Hicks is used slightly clumsily, if you will, to just say a situation in which dollars are maximized. But that's not the correct definition, and it creates those sort of problems. Now, a Kaldor-Hicks improvement, on the other hand, is any change that raises the dollar value of social resources. Okay, so if you have a scenario in which the dollar value of social resources is not maximized, a Kaldor-Hicks improvement is possible, and you keep making Kaldor-Hicks improvements until you get the maximum dollar value of social resources, and then you hit Kaldor-Hicks efficiency. Now, it's important to confuse you here a little bit. What is the relationship between Kaldor-Hicks efficiency and Pareto efficiency? Every Kaldor-Hicks efficient situation is Pareto efficient. So let's just look at this first part of the sentence first. Every Kaldor-Hicks efficient situation is Pareto efficient. Why? Because if you're maximizing the dollar value of social resources, any move away from that will decrease the dollar value of social resources, and that loss will have to be borne by someone. In other words, any move away from the situation will make some people worse off without making others better. And so Pareto efficiency requires that you can't make others worse off. So Kaldor-Hicks efficient situation is also Pareto efficient. But most Pareto efficient situations are not Kaldor-Hicks efficient. You can have scenarios in which you can move away from your current allocations in a way that increases dollar value, but it would make others worse off. And so every Kaldor-Hicks efficient situation is Pareto efficient, but most Pareto efficient situations are not Kaldor-Hicks efficient. Okay. And to confuse you even further, every Pareto improvement is a Kaldor-Hicks improvement, but most Kaldor-Hicks improvements are not Pareto improvements. And let's unpack this a little bit. What is a Pareto improvement? It is a win-win. When a win-win is in play, the value of social resources should also increase. So a Pareto improvement must be a Kaldor-Hicks improvement. But again, this matches with the second half of the previous sentence. Most Kaldor-Hicks improvements are not Pareto improvements. Why? Because most Kaldor-Hicks improvements, that is an increase in dollar value of social resources, might be making others worse off. If this is confusing you, you're not alone. This slide catches off students and has caught off students for the last decade that I've taught it. And so let's try and make things easier with an example. So assume that you value a car that you own at 20 lakh and I value it at 23 lakh. So you're the seller and I'm the buyer. The friends who would ask you for a ride will get value from your having the car over the lifespan of the car at 5,000 rupees. And the friends, my different friends, would value my having the car at 5,000. Now, those values don't have to be equal, as you'll see when we do the math in a bit. If I have the car, the situation is Kaldor-Hicks and Pareto efficient. Why? It's Kaldor-Hicks efficient because what is the value of social resources when I have the car? Think about that for a second. And why is it Pareto efficient? Because there's no way to dislodge me from the car without creating a loss scenario to someone or the other. And you should pause and think about whether that makes sense to you. If you have the car, the situation is Pareto but not Kaldor-Hicks efficient. And now you should be really stumped, and this should become easier in just a second. So if you sell me the car, the social value on the car rises from 20 lakh and 5,000, that is 20 lakh of value to you and 5,000 to your friends, to 23 lakh and 5,000, 23 lakh to me, 5,000 to my friends. But even though the total value of the car has increased socially, including social aspects, your friends lose 5,000 rupees. They haven't been compensated here. And so if I have the car, the situation is Kaldor-Hicks efficient. The dollar value of resources has been maximized when the car is with me. And Pareto efficient because taking the car away from me will make someone at least worse off. If you have the car, the situation is Pareto efficient. Why? Because when it transfers from you to me, we're making someone worse off, even though we're making others better off. But isn't Kaldor-Hicks efficient? Because you could improve the dollar value of these resources. So I hope that makes a bit more sense now. But this should strike you as limiting, right? And the limitations of Kaldor-Hicks are that Kaldor-Hicks is described as potentially Pareto efficient. That is, if we reach a scenario in which the dollar value of social resources is maximized, you technically have enough money in there to compensate others. The 23 lakh and 5,000 was better than the 20 lakh and 5,000, and the loss that's been made is way less than the gain of 3 lakh that you and I have made combined, right? So assume that the car was sold for, let's say, 21 lakh. So you've gained 1 lakh in value, I've gained 2 lakh in value. Whatever the price is between 20 lakh and 23 lakh, 3 lakh rupees of gain has been created between you and me. So that 3 lakh outweighs the 5,000 that your friends have lost. And so a Kaldor-Hicks efficient scenario is potentially Pareto efficient because we could potentially write them a check for 5,000 rupees. But when we say you could compensate others, you're really ignoring two things. One is transactions cost, the cost of finding out who those friends are and bargaining with them, writing a contract with them or whatever. But most importantly, politics. So typically when there are losers being created, there's a politics of whether they will allow something to go through. And more importantly, when there are disproportionate winners in a scenario, they then become powerful and can create rules that disallow the type of compensation that we're talking about. So saying that Kaldor-Hicks is potentially Pareto efficient is a bit unrealistic. Again, Kaldor-Hicks is based on monetary valuations, not utility or happiness. And then we have to think whether efficiency is the aim or just one aim of an economy. So let's go back to this diagram and think, well, let's imagine that we are considering going back from the price ceiling. Okay, let's go back to this diagram now and consider something, which is so let's go back to this diagram now and consider something further. We know that when we have a price ceiling in place, there is a deadweight loss being created or a loss of efficiency that's created. But consider inframarginal meaning before the margin units. In this case, let's consider the unit where I've drawn this other vertical line. What's happening there? What was happening there when the price was determined by the free market was that the consumer valued that unit equal to this, from the line between the x-axis and this blue dot, and the seller was willing to sell it at the lower dot. In this space there was a gain. In this space is the total gains from trade possible. Let's go back to this diagram now and take just a unit here. Now for this unit, the amount that the consumer is willing to pay for it is this amount, and the amount that the supplier needs in order to provide that unit is this amount. When you have your competitive market forces deciding the price, the equilibrium price is in play, the price is this, which means that the consumer gets a consumer surplus of this amount, that is the extra change that he pockets by not having to pay the maximum that he was willing to pay. And the supplier pockets this amount, which is the maximum, which is the gap between what she needed to supply that unit and what she actually was able to get for that unit. When you affix a price ceiling though, you've created a difference, which is that now the producer only gets a little bit more than she needed at a minimum, and the consumer gets way more than he needed. He gets a much lower price than he was willing to accept, and so that those gains from trade have gone from one party to the other. And so this amount is the amount that has been taken from the producer surplus and been converted into consumer surplus because of this lower price. And this is true for all of the units which have experienced this drop in price. So this entire region is a transfer from previously being a producer surplus to now being a consumer surplus. So when you're looking at this scenario, you really need to think about sort of efficiency. If you go by Kaldor-Hicks efficiency, Kaldor-Hicks demands greater efficiency, and so it would say we should not have the price ceiling in place. We should instead have the free market outcome, and the gains that will be made by producers we can use to compensate consumers. Whether the free market outcome is Pareto efficient or the price ceiling outcome is a Pareto efficient depends on your starting point. If you're starting from any of these points, it is Pareto efficient, because a move away from that point creates a loss for at least one party. And this is the frustration with Pareto, that it doesn't really distinguish between two very different outcomes in terms of whether it considers them efficient or not. And so if you have very easy redistribution, Pareto will say, fine, let's move to the Kaldor-Hicks point, and the loss being made by some parties will be compensated by redistributing from others. But typically we don't assume that to be possible. So after having talked about both Kaldor-Hicks and Pareto, it's important to start summarizing what it is that economists mean when they're considering different alternatives. So here's the punchline. Any comparison of alternatives typically requires interpersonal comparison of utility and an estimation of the size of the sums involved. Interpersonal comparisons of utility means considering whether the gain of the consumer is greater than the loss of the producer. Interpersonal comparisons of utility are really actually quite difficult to make, but they're also essential. If you're given two policy options and one makes some people better off than others, and sometimes a policy makes some people worse off in order to benefit others. For example, you're constructing a motorway and it runs through someone's farm and creates, even though you compensate them, you can't compensate them enough. And so we have suddenly a scenario where you have to make this one person worse off, but creating the motorway will benefit others. Philosophically, can you say that the loss to that person is outweighed by the benefit to others? It's very hard to do that in a rigorous theoretical way. But the other thing we should do is calculate the size of the orange area and the size of the pink area. In any policy that we're looking at, we need to try to compute the size of the sums involved, whether that be in increases or decreases in efficiency, or whether that be in transfers that are being made. And oftentimes what happens is that we don't end up making those sort of comparisons. So where does this leave us? In the last two lectures, what I've tried to argue is that first, you can use the idea of rationality to predict how people will behave. And you will have noticed that we've used this idea of rationality throughout this example of the price ceiling. We assumed that people will respond to a price ceiling by changing their demand and their supply. And so that is what we mean when we say that economic models are predicated on or are based on rationality. The other thing that I've wanted to explain to you is that it's not enough to just think what makes for greater economic efficiency. We also have to think about distribution, and we have to think about how we need to deal with interpersonal comparisons. I've explained to you two simple ways to adjudicate between different policies. Kaldor-Hicks, which says let's maximize the value of resources and try to create compensation, and Pareto, which says let's only change things when we can get a win-win. The problem, of course, being that it's hard to create win-wins from every scenario. These are important because when you're engaging with the policy, it's important that you pay attention to both distribution and efficiency issues. And I think what I found over time is that I'm much more comfortable with the positive side of economics. That is, I'm much more comfortable describing the impact of different policies using the rationality model than I am with more assertive normative stances, where we are saying one policy is definitively better than another. And I think practically, if you want to think about what economists have to say about the economy, we need to find a way to practice economics. And I think the right way, the good practice here would be if we make clear and transparent whether there's a distribution difference or whether there is an efficiency gain or loss from a particular scenario, and then let the political forces or public decide what type of policy it wants. So this concludes the introduction to this course. These were slightly more technical classes, and we're still experimenting with this sort of online teaching. In the next class, we'll start talking about what is the value of trade. Thank you and take care.